So hello everyone, my name is Ain Farisha from 4th and right now I'm going to give to you guys my presentation for my PBL Physics Chapter 3 Gravitation, specifically 3.2 Kepler's Law. So a brief introduction to the person that we're studying today, Johannes Kepler. Johannes Kepler is a German astronomer and he formulated 3 laws that describe the movement of planets around the Sun. So first we'll be discussing of Kepler's first law, also known as law of orbits, can be described as such: all planets move in elliptical orbits with the Sun at one focus. The planets in the solar system have elliptical shaped orbits, and the Sun always stays on a focus on the ellipse. The major axis will always be longer than the minor axis. Like most orbits of the planets have major axis and minor axis of almost the same length. As such, like the shape of the elliptical orbits is almost round. Planets can be assumed to make circular motions around the Sun. The radius of orbit also is the average value of the distance between the planet and the Sun. Second on Kepler's second law, also known as law of areas, can be defined as a line that connects a planet to the Sun sweeps out equal areas in equal time. So observe the figure. We're labeling it area X and area Y, point A, point B, point C, and point D. So if like a planet takes the same amount of time to move from point A to B and from C to D, then the area X is the same as the area Y. So since distance in AB is longer than the distance from to CD, and like the planet is moving at a high linear speed from A to B compared to C to D, but they take the same amount of time. So the area X is equals to area Y. And last one, Kepler's third law, also known as law of periods, can be defined as the square of the orbital period of any planet is directly proportional to the cube of the radius of its orbits. And from here, so a planet which orbits with a larger radius has a longer orbital period. As such, planets which are further from the Sun takes a longer time to complete one orbit around the Sun. For example, the Earth takes 1 year to complete one orbit around the Sun, while Jupiter takes 11.9 years to make one complete orbit. Speaking of, so Kepler's third law can be used for this equation, which says the orbital period of a planet is directly proportional to the radius of orbit. So Kepler's third law can be formulated using the centripetal force and also the Newton's universal law of gravitation concept. So from both of them, we could get v square equals to gm over r, and we will also take the linear speed of planet, which is v equals to 2 pi r over t, and we substitute the linear speed of planet into the centripetal force, and do the equation, we will get t square equals to 4 pi over gm in the bracket r cubed. So we get t square equals to k r cubed, where the constant k equals to 4 pi over gm. And that will be all. Thank you for listening.